Yeah, so the first thing we wanted to do was just have everyone introduce themselves. We want to know who you are, what department you're in, if you want to tell us if you're a grad student or a professor or whatever, and then if you have any previous negative experience that you want to share from learning math yourself or from teaching math, that would be really great. So I can start. I just told you my name and department and stuff. And as part of that dissertation chapter that I mentioned, I was teaching about matrices to biology students, and they kind of all saw these numbers and went, oh my god, we're supposed to be learning biology numbers. And then I had them working in Excel, and I was kind of shocked to see seniors in biology majors that had never used Excel before. So it's interesting to try to figure out ways to get past that shock and get them interested and excited about using math and biology. So, do you have a negative experience you want to share?
Sure, I'm Diane Johnson from the math department at Humboldt. I have been teaching since I was about 21 when I became a grad student. And when I was a grad student like you, I had a guy in my remedial class who had been in Vietnam, and he was deeply traumatized and had like shut it away. He never wanted to talk about it. He didn't tell his wife anything. And then one night he went to a Chinese restaurant, and it all came back at him. And I mean, just swamped him, all these emotions. He was like in the closet hearing guns going off. Anyway, why I bring this up is, of course, he couldn't finish his remedial math class, but it was an incredible example for me of something I could not handle, and the way that the trauma, well, it went from the cerebral kind of stuff that math is, all his energy went down into the bottom, reptilian part of his brain that was fight or flight, survive. And he could not, of course, do mathematics. And trauma fascinates me, and I've experienced some of it myself as a child. And so, that was a huge teaching experience for me. And so that's my story. I'm sticking to it. Thank you.
So, we're going to start with a quick video. This is from a community college in Minnesota, and I just kind of thought it was hilarious, so hopefully you also enjoy it. So, you guys all know why to study math, but I really, really like these quotes that you could use with your students or whatever if you wanted to. So I really like this one from Charles Darwin. Of course, everyone knows, came up with natural selection, was a huge famous biologist, right? But he said, I have deeply regretted that I did not proceed far enough at least to understand something of the great leading principles of math. For men thus endowed seem to have an extra sense. And in fact, if he had understood a little bit more about math and known about the work of Mendel, the pea plants and everything, then he actually could have gotten a lot farther in learning about evolution and natural selection and explaining it genetically. But even though that work was happening at the same time, he didn't know anything about it. And then we also have a quote from Galileo.
Galileo said, the universe is a grand book which cannot be read until one first learns to comprehend the language and become familiar with the characters in which it is composed. It is written in the language of mathematics. And the last is, of course, I've probably heard this, but do not be troubled with your difficulties in mathematics. I can assure you mine are much greater, according to Albert Einstein. So we're just mentioning, it's very important to understand mathematics, to do science, as you well know. I think we're going to move to some of the symptoms of the definition. I'm sorry. That's yours.
Okay. So there are a couple different definitions of math anxiety, but they're all pretty much what you would expect. This was the first one from the classic paper about math anxiety when they first came out with the survey to evaluate math anxiety, the illustrative research on math anxiety. Feelings of tension and anxiety that interfere with the manipulations of numbers and the solving of mathematical problems in a wide variety of ordinary life and academic situations. So I really like that they point out ordinary life, because sometimes people can struggle with math anxiety when they're trying to balance a checkbook or figure out the tip at a restaurant or something. And then here's a slightly more recent one, really short one. Attention, apprehension, or fear that interferes with math performance. And then this one was from a paper that was in, I think, PLoS 1 last year, which is adverse emotional reaction to math or the prospect of doing math. And in this paper, they actually had people hooked up to an MRI machine while they were doing either math or verbal problems, and they would give them a cue right before they did the problem with a like a square or a circle to tell them if they were doing a verbal or a math problem. And when they just saw the cue for math problem, they didn't even see the problem yet, they would start having their pain network activated. So, and that was only in people that, according to their survey, said that they had high math anxiety. So I thought that was really interesting that this is the first time they've been able to show that math anxiety can be activated before you even see the problem. And you're just thinking, oh God, math. It's pretty interesting.
So in terms of symptoms, maybe you've seen some. There are the physical symptoms and there are the physical, the psychological, the emotional. Can anyone comment on any of these they may have seen in teaching or felt themselves? I know sometimes I just, I get really distressed and I have a hard time even focusing when I get really worked up. I think I can't function. Anyone else seen this?
I see the helplessness a lot.
Yeah.
They just basically don't want to even attempt it anymore because they're like, I'm just not going to get this. And they just resign to it.
Yeah, it's hard.
I've had a lot of clients start crying.
Yeah.
Yeah, and it's really sad because at that point they kind of need to stop and start, help them calm down and realize that it's not the end of their life, that they can pass.
Thank you. Anybody else?
By the way, we want this to be pretty informal, so if you have any questions or anything at any point, please say them. I tried to put all the text from the PowerPoint into this handout, but left room in case you wanted to add things yourself, because I don't want you to have to be writing down a PowerPoint. I hate having to do that. So it's there, and we're also going to be putting it online, so hopefully you can just ask and think. So there are a whole bunch of different surveys that people have used for doing research on math anxiety. The first one from the 1972 paper had 92 questions, but it's kind of hard to get too many people to do quite that long of a survey. So they came up with a shorter one that has 25 questions, and you rate basically on a scale of 1 to 5 how anxious that situation makes you. And this survey, which is the short or abbreviated math anxiety rating scale, has been used. It's been used in research for more than 600 students. It's very internally consistent, reliable. So people that take this short test and the 92 question test pretty much get the same result. So, and that is the second to last page in your handout. So if you guys could all take a couple minutes and go through that whenever you have a chance, and then it goes you get 1 point for not at all and 5 points for very much. So if you want to, after you're done with that, go through and add up what your scores were, and then we'll see how that matches up with the math anxious scale. I'm going to guess that we're probably not going to have a very high math anxious in this group, but just so you know some of the situations that people deal with math anxiety.
They looked at over 600 college students. The mean was 31. The standard deviation was 16. And they believe you have high math anxiety if you scored over 38. I don't know if anybody would cop to it if they did, but oh, okay. And then low if it's less than 24.
No, wait.
There's 25 problems.
It's 25 problems, so I don't know where that came from.
It must be 0 to 4.
0 to 4. Yeah, I suppose. So we'd have to shift it down. But
So wait,
anyway,
yeah, could it be 0 to 4?
It has to be.
It has to be.
Yeah.
So then what would be my math score?
Because I really don't feel like I'm bad,
Yes, otherwise you have
So we'd have to take away 25 because there was one added to
Yeah,
each
so you just
one.
subtract 25 then.
Subtract 25. because there's 25 questions and 1 point more per question than would have been on a 0 to 4 scale. So if you take away 25,
Hi.
so it's not very high at all, lots of zeros.
No.
Okay, little math there. Good job. So,
Yeah, so if you have students that you think might have math anxiety, you could have them try doing this, and if it's really high, then you might want to send them to the counseling center here. So we'll talk in a few minutes or later about what the different resources here are at UCSC. And I don't know, can you guys read this cartoon? I thought it was really funny. It's Lucy saying, you know what, I think you have math anxiety. If I asked you how many ways that 9 books could be arranged on a shelf, what would be your first reaction? Ah! See, you have math anxiety. So that's how she evaluates it.
so we talked in that video about the prevalence of math anxiety, but in a study in 78 by Betts, 30% of the students had some math anxiety, and then 85% in introductory math courses were in this study by Perry. So there's quite a bit, and I think we keep going here. Higher in females than males, higher in Hispanic groups than any other ethnic, and more likely in students with inadequate math backgrounds. And that's really hard because our underrepresented minorities often, unfortunately, their schools aren't as good, don't equip them as well as some of the other schools, so they come in at a disadvantage, and then they've got that anxiety because they think everybody else can do it, and it's just kind of a snowballing effect. So thank you.
And there are also a lot of impacts of math anxiety. Most of these are just studied by correlations that people that score high on that math anxiety survey also exhibit more negative attitudes toward math in other ways. They tend to have lower math performance, including on standardized tests like the quantitative SAT or the quantitative part of the GRE. They tend to have lower grades in math courses. They tend to take fewer math courses voluntarily, and they tend to avoid majors and career paths that depend on math or quantitative skills, like all of our STEM majors. The math performance one actually, that has been shown to be an effect to some extent, because there are treatments for math anxiety that psychologists can do that don't address math performance at all, but directly address the anxiety. They're not actually teaching math, they're just doing talking about the anxiety. And it does lower people's math anxiety and increase their math performance without ever actually teaching any math or anything. So the research says that actually is showing a real causation effect. Ingrid can testify that in our department, at least, we talk a lot about correlation, not causation. So I wanted to throw out that there's one tiny evidence of causation, but it's pretty hard to do experiments with people, of course. So I think I'm guessing in psychology, they tend to be a little more okay with correlation than I tend to be in my research. And these studies also show that math anxiety is not related to verbal IQ. It is related to math IQ, as you would expect, but it's not related to verbal IQ. If you have math anxiety, it doesn't necessarily mean that you're stupid or anything like that. It just means you have math anxiety. And it is also related to another kind of anxiety, which is called test anxiety, where you just get anxious at taking tests, whether it's math or not. And people that suffer from math anxiety often tend to have test anxiety as well. Or sometimes just math test anxiety.
So talking about causes, have your students ever kind of sat down and told you why they believe they suffer from this?
Or why they struggle with math in general.
Yeah.
Yeah, Zoe.
Something I hear a lot from my students is just, oh, well, some people aren't good at math, like I just wasn't born, like some people are good at math and some people aren't, and I'm just not. And I try and like talk to them and convince them that they weren't born with like an anti-ability to math. But they're like, no, some people aren't good at math, and that's me, I'm just not good at it, so I don't even want to deal with it.
They call that a math myth. There are a lot of myths in our society, but that's a major one. And You know, I tell them, you know, when you first were gonna sat down in the driver's seat and you thought, acceleration pedal, rear view mirror, turn signal, oh my God, I'll never get this at 70 miles an hour. And now you're doing it with your Starbucks and your music and you're talking and you got your ear pods in. You know, it's like it's just a matter of practice. And, you know, some of them can relate to that. I don't know. But that's a great one to bring up. Yes.
I think a huge one too is having a bad experience with a teacher, and also, I think unfortunately there are a lot of teachers that have anxiety themselves about it, or not fully comfortable with the material, and they give that to the students. And like I've had K-12 teachers come to me for tutoring. I've had a lot of math ed students come to me for tutoring. And to me, I think as an educator, you need to know when you shouldn't be teaching a subject, or you need to bring your skills up to par to be able to teach it.
Yeah. I had a comment on that too. Maybe you'll be familiar with this paper, but I'd love to find it again, but I haven't been able to. There was a study done a couple years ago about math anxiety that talked about the difference between the levels of math anxiety in young women and young men. And women, or at least girls in school, tend to have higher levels of math anxiety. And they correlated that back to more primary education, young teachers being women, and that a lot of those teachers didn't have higher level math, so they may inherently have a higher level of math anxiety. And girls, because those teachers are women, tend to identify with the teachers more than the boys would. So that anxiety is then transferred to the girls more than it would be to the boys, because the boys aren't identifying with the teacher as someone that they're exactly going to be like, whereas the girls might be. I thought that was interesting. I don't know exactly how they went through making all those correlations and what the exact methodologies were, but I was wondering if anybody had read that or.
I read that one. That was
Yeah.
interesting.
That's actually this paper right here.
Okay,
It's
cool.
on your list of
Oh,
references.
good, that's great.
Yeah, it's a 2010 paper that was in the Proceedings of the National Academy of Science about how girls that have female teachers with math anxiety also tend to be math anxious themselves.
Yeah.
It's a really interesting paper.
Mm-hmm.
As a lot of students, at least I had, complained that they were taught math by their football coach also, that they weren't actually someone involved, like who had done math and then was in high school teaching math and just ruined the experience for them because they weren't accurately teaching them anything. So they didn't feel like what they were learning, they didn't feel like they were learning anything because the teacher couldn't actually teach them anything about this stuff. And then they would be tested and they'd get wrong because they just couldn't understand the teacher.
I thought that was interesting, and I went around to my department and talked to some of the female professors that use a lot of math, like seismologists, those kind of people that use high level math, and they all had male elementary school teachers, at least one or two, when they were learning, starting to learn math. They had at least one or two male elementary school teachers. So I thought that was really interesting. I mean, maybe it's just.
Now that you mentioned it, all my elementary school teachers were female. I'm not even sure I about that before.
But you are, you're breaking that mold, that
Of course, yeah.
cycle. You guys
Yeah.
are great, the women here, and also the men. And then it's generational, because then your mother has got it, and then she models that, and you're breaking it, the cycle, which is really cool. Really cool.
I have a question. So, when you read these studies, like on the news, that the United States is woefully well behind, what other countries that have much better math? I mean, is that? I guess I'm not sure what the question is, but is that some demonstration that we could do? It's possible to do better. I mean, I'll tell you, I went to elementary school for brief periods in Asia, and we wouldn't be allowed to do what they do. They actually, this is a long time ago, they may not do this now, but if you failed a math test, you would go up to the front of the class and you would be lashed, depending on how badly you failed. Yeah.
Wow.
Like slapped on the palm with, but it hurt, like it stung. But I think by the end, she did very well.
Can I understand the culture? The culture in Asian societies is not that math is innate, but that math is learned, and that you work hard enough to learn it. So it's a little bit more driven.
But I'm just wondering if the anxiety is still high there or not, or I don't know. I guess there's.
They're too anxious about being hit to be anxious about math.
Yeah. But to speak of this myth thing, like if all the students in whatever Singapore can figure this out, like what's so different about?
Can I point something out?
I
Yeah.
don't know.
Zoe, go.
So, I just want to point out that those studies don't take into account like disparities in who's doing well at math and who's not. So if you actually look at kind of the top learners in the US, they are at the same level as learners in those other countries. It's just that we have the most enormous disparities in terms of those students who are not getting enough resources, those students who are getting enough resources. So when people make this big deal of like, oh look, these Asian countries are being able to produce good mathematicians and we're not, they're totally overlooking all of these other issues, and it's not actually that big a disparity when it comes to those students who we are addressing really well. They're doing really great in math comparatively to other countries. But we also have a lot of students who are not doing well, and that brings it down. So I think that that's more about kind of distribution of resources than math anxiety. Because I'm pretty sure that there's a lot of anxiety in Asian communities as well.
Yeah, I mean, one of the things that they think really contributes to math anxiety actually is like public embarrassment. Like they had in that video, you know, if you're getting yelled at for not doing your math correctly, you're getting a lot of pressure. That really can contribute to math anxiety. So maybe the students in those classes are just used to the embarrassment because they get embarrassed all the time. I don't know. But yeah,
It might be
I've never-
different now too. That was long.
I've never heard of any studies of math anxiety in other countries. Actually, it's still kind of a growing field. It's kind of a small field, actually. Most of the papers that we're talking about today is pretty much all the papers on math anxiety that I could find. And there's not that many.
Interesting.
My theory is that they practice a lot more. They just do it over and over and over again. There's like a lot more repetition, and that sort of helps to reduce these efforts.
I think part of the problem too is the prevalence of calculators and computers in like arithmetic, and then a lot of students nowadays don't really learn how to do basic arithmetic without a calculator, and so it's kind of like a fundamental issue, and then they carry that on for all the math classes they have to take. Because it is interesting, because I've had older students too who probably didn't have calculators when they were in elementary school, and then I've had a lot of younger clients, and it is interesting how then a lot of people will stress out about just doing basic multiplication or adding, and I think that's definitely a problem.
So you see that more so with the students who have had calculators, like throughout elementary school, and
Yeah.
for the basic foundation of like arithmetic.
Yeah, like a lot of students who can't, like they'll immediately jump to their calculator to compute a sum, and that's like a basic sum, single digits, like, and those people usually have worse math anxiety than people who can do really level arithmetic.
They allow calculators in elementary school?
Yeah, I know.
I definitely
don't
didn't know
allow
you
my
had
clients
that.
to ever use a calculator. It's like, why? You don't need it.
Ridiculous.
It's pretty frustrating.
I don't think I got a nice calculator until like at the end of high school in calculus.
Yeah, I mean, I believe though you don't even need it really in any class except for statistics. You don't need it. People think you need it in calculus or something. You don't need it.
So these causes that were put in here, they're more from anecdotes, just like the ones you guys are giving. There really haven't been any quantitative studies of the causes other than that one paper about the female teachers that I mentioned. So yeah, prior negative experiences with math, fear of looking or feeling stupid, fear at the wrong ability level in the course. Like she's saying, if you're unprepared, same thing. Also because math is different from a lot of other things that people study. Like if you miss a day, it can be really hard to catch up, and you can't do the next thing if you don't know the building blocks. And also that we're applying math all the time, so it's not really something you can just memorize. You have to know how to do it. And also that math has a totally different vocabulary that sometimes can be the same words, just like in science. It can be the same words that we use for ordinary things that mean something totally different in math, which you guys all know this stuff. And then also the math myths.
So the first, of course, there's a math mind, right? Boys are better, the Chinese are the best. That is a saying that Kristin has heard. I don't know if has anybody else heard that saying?
The what?
This one, the boys are better, the Chinese are the best.
I haven't heard that saying, but everyone, when they find out, like, I'm a female and I do math, I like it, they say I have an Asian brain.
And
Yeah, I've heard that
Yeah.
so many times, and I'm like, I what?
Wow, it's so racist.
Yeah.
It's, there's a best way to do a math problem, you know, probably heard that.
And you guys all, of course, know that there are usually many ways to do that problem.
Yeah, there's lots of ways, of course. It's got to be quick or it's impossible. I think in elementary school, most problems on the average take 5 to 10 minutes to solve, whereas like some in calculus, as you know, or in the sciences take years or they aren't solved at all. And people think if they can't do it in 10 minutes, then the teacher gave them the wrong problem or they don't understand and they quit. And that's something as an instructor we can point out. So that intuition, imagination, creativity, and feelings aren't a part of math, I think, is a myth. You know, that you can't, your humanness is gone. There's the human side and then there's the math science side. They don't merge. And then math isn't real. I don't know, some people seem to think it's, there's actually, you know, they're talking about getting rid of math departments. Have you seen this? There are some national science, there was an article that was going around my department just last week that they were saying that a lot of math is just a stumbling block for other majors and that they should parse out the math that can be used in other fields and math departments are pretty much obsolete. I'm serious. That's cycling right now. So administrators are, of course, know these things. Yeah. Math is mainly arithmetic and math is boring, which is such a sad thing because I think math is so exciting. But I don't know if there's any others. No. And then about trauma, I mean, there have been some studies that say that childhood trauma affects your ability to concentrate, that when you're traumatized, you're focusing in your lower part of your brain, your reptilian brain, as I was saying, and the thinking part of the cortex is hijacked. And when you're in fear, you have what's called hypervigilance. I'm sure you're aware of this, where you're just aware of everything around you. You're frightened. You don't feel safe. Your muscles are tense. You focus on cues of any kind of threat. The anxiety heightens. And behavioral impulsivity is you will act without thinking because you're so tense and so frightened. So, for example, in a testing setting, you know, just put a 2. You know, well, just put a 3. Well, I can't do anything, and you just want to run. I actually had a student fall out of a desk when he was taking a test. He got that freaked out. And it's just this hyperactivity of the fear response. So anyway, this is stuff that's been studied now.
And there's also some research on the cognitive science and neuroscience behind math anxiety that's come out in the last few years. And one of the things that they've shown is that your working memory, which is defined there as a short-term system involved in the regulation and control of information relevant to the task at hand, that, you know, if you don't have math anxiety, you can spend your whole working memory on the problem that you're working on. But if you have math anxiety, you're spending like half your working memory being anxious. And so it's just a lot slower and harder to do the math problem. And they've actually been able to show that to some extent with some really interesting experiments. And then there's also the research that I mentioned to you guys about people having experiencing pain and threat detection in their brain at just the anticipation of a math task as well as during the actual math task, which I thought was a really interesting study. And so to tie up everything we've been talking about, I liked this figure from one of the books. If you guys want to come up and look at these books in a few minutes, feel free. This is one that Diane really likes. That's Conquering Math Anxiety by Cynthia Ream. So a lot of the stuff we're talking about today is also from that book. And so I like this figure of previous experiences result in negative self-talk, result in anxiety, result in the psychological and the physical symptoms, which then result in the poor progress in math, failure, and avoidance. So, hopefully any second here, we'll be getting our pizza.
Pizza is here.
Oh,
It's set up.
that's here. Cool. So when we come back, it would be great if you guys could kind of talk in small groups about what maybe has helped you reduce your math anxiety and what you've tried that's helped others and what some of your ideas are. There's some blank space on there, so see what you come up with. And then we'll mention what has been done in the research and what some of the resources are here at UCSC. So go for it. Let's get pizza.
A lot of good stuff. Actually, why don't you talk about this?
So, I've had this, reading a little bit about it, professional experience, I think collaborative work, working in groups, can be very helpful to students. I mean, first of all, if you get stuck, someone else can help you. That helps. I think the idea that you're not struggling alone is good. I think asking for help from a peer, from a fellow student, is easier than asking for help from a TA or professor. So they're more likely to ask quote-unquote dumb questions, less intimidating. I think just the fact that just being around other people, having the same experience as you can just help you along and see that you don't stand out, that you're not abnormal in some way because you are struggling with this. That's actually the experience you should be having, because that's the experience that everyone is having. So, yeah.
And that definitely is something that has been supported by the research. Also, one thing I've been meaning to remember to point out is that I actually worked with an education professor last quarter to work on strategies for large enrollment science courses. And so we actually wrote up summaries of education research on a bunch of different strategies, including collaborative and cooperative learning. So I mentored this link on there, but I will email you guys the list of strategies we came up with, and I will put that on there.
Do they use the clicker here at the school?
iClicker.
iClicker? Okay.
It just depends on the professor.
Oh,
Yeah, we can.
I haven't taught a class at CC yet, so I don't know.
Can I say?
It's optional. But there's
Some of the disadvantages, I've had them in groups and someone will sit there and not do anything, and then somebody will solve a problem and they'll take the paper and copy it down and
Yes.
never understand. And one way I've tried to battle that is a technique called the whip. I don't know if you've ever heard of this, but you get them all up and you line them, the most confident here and all the way around to the least confident here about a particular problem. They've all got the paper in their hand. And then you pair the extremes all the way to the middle, and the most confident explain to the least confident and all the way down. And you try to make sure everybody in the room can solve that particular problem. I don't know.
So that's something you could do with a really hard problem.
Mhm.
Another thing that is actually in that summary that I wrote up, that I learned for science stuff, is just, having both group and individual assessment. That if they know, I'm going to have to take a quiz myself, then hopefully they'll learn how to do it themselves, as well as copy someone, in addition to copy. One of the other advantages of that is that sometimes, like a lot of you guys talked about how if you've been doing math for so long that you're comfortable with it, and so it's hard to explain it to someone else that's just learning. And so sometimes it's easier for someone that has just learned it to explain it. They can explain it in different ways that might make a little bit more sense. And so that's one of the really good things about group learning also, is that sometimes they can phrase things in a way that your peers can phrase things in a way that makes sense to you that the teacher didn't necessarily think of.
Something that I'm really interested in is thinking about math anxiety in the context of a lecture. You're the lecturer, you've got a big class. What are some of the triggers of math anxiety that we can learn to avoid? So I don't know if I would be interested to know if there's been any research on this of just what are the phrases or things that a lecturer might say unintentionally that are going to raise up math anxiety in the classroom. And we were talking about how one of the things we try to avoid is saying, well, you should all be able to do this. This is really easy. because I think that that's like when you say this should be easy and then it's not easy for them, then it kind of seems to be a trigger. But there must be other things.
Have you heard Dr. Eric Mazur? I think he's Harvard, but anyway, he's a math guy, and he says, they've done brain studies, like if you do like an activity like washing dishes, there's certain activity in your brain or something else. They said they put these things on people, grad students like you, for like 3 days. And then they took them out and they figured out what you were doing and where your brain activity were. There were spots where there was nothing. And you know what those spots were? Lecture and TV. I'm serious. So what students do is they think we're a TV on some part of their brain. Okay? So what we got to do is kick them out of that mode. And I don't know that anxiety is a great idea, but when you say, you're doing a lecture, his whole story and that workshop he did all by lecture mode. So that seemed very contradictory to me. But anyway, I think just the more we can get them doing something, And with the clickers, I use clickers and taught people to use clickers for years, but you can do this. I don't know if you've ever done this, but you can say, okay, for example, with calc, is this product, quotient, or composition? Okay, 1, 2, 3. I'm going to count. 1, 2, 3. Put your fingers out. Well, nobody can see your hand, theoretically, so you're not going to get shamed by going like this and everybody else is going like this, right? But you don't have to buy a clicker. And as an instructor, you get that immediate response that, wow, they're all saying 2 and it's 3, And so that is just an action, one thing in a lecture, so it gets them more active. And I think that the more that they can do it, do something in a class, as opposed to just hear or watch somebody else do it, that they're not like a deer in headlights when they see it at home, and they're less likely to think, that it's just impossible. Anyway, I went off, but yeah, go ahead.
Related to the clicker and kind of the group thing as well. I had a teacher who gave everybody 10, like numbers 1 through 10 stapled together in like a little book sort of thing. And then they would ask a question, and kind of like the clickers, you'd flip to the number you thought it was, but you'd hold it like this in front of you. And then he would, say, okay, and then he'd have you turn to the 2 people next to you and show them what you got. And then as a group, you would discuss why you chose what you chose, and you'd sort of try to convince the other people that you were right. Usually, they would come to the correct conclusion because the other reasons didn't make as much sense, or somebody was just guessing because they didn't understand it at all. But it took the whole group to come to a new conclusion, and then again, he would ask, okay, what are your new numbers? And everybody would hold up their new numbers. And it was a way to kind of not only get the working with it and paying attention while you're doing it because you're flipping your cards, but to get the group interaction, but for a really short-term, really simple question where it wasn't like the whole lecture or a whole lot of time. It was just a couple seconds for a really simple question.
And you really hear real mathematics going on instead of just, I think it's this, and then they forget. It's like, I think this for this reason. And it's very exciting. And I've had a whole class talk themselves into the wrong answer. But that's exciting too, And it's supposed to really work with underrepresented minorities for some reason. I'm not sure all the data, but this kind of stuff. Anyway, sorry I interrupted you.
So the strategy that she was just talking about, where you do like a clicker or flip card or whatever, and then turn to your neighbor and talk about it, that's actually a strategy that Eric Mazur at Harvard that she mentioned has done a lot of work on. He calls it peer instruction. She wrote a whole book, the Peer Instruction Manual, and there's been a lot of papers in science as well as education journals about that. And so if you're interested in learning more about these active learning and large course strategies, I would be happy to talk to you about them. And we talk a lot about that research in those reviews that I just mentioned, and each of them is just like 3 to 5 pages, pretty quick, easy to read, with a lot of references to go on if you want to learn more. But let's try to maybe focus a little bit more specifically on math anxiety, because the ones you're talking about are great for math anxiety and also other things.
So they say like the disadvantage of some may not contribute, like say in a math problem, and you see it a lot. Has there been any work done where you show that you have them all work individually on their own, and then have them come together and discuss kind of like the card thing? Does that work, or do you still see that there's a lot, like the same number of students like copying, like they know they're going to get in a group, or like is that like a good way?
I don't know about math specifically.
Yeah.
The clicker stuff, there actually have been papers where they've done like that, where they they'll ask the initial clicker question, where you have to work on it on your own, and then you work with a group, and then you go back and answer that same question again, and then they ask a second question that's similar but different question, and answer it again. And at that point, most of the students do actually answer the second question correctly.
Okay.
So if you do the right design with the whole peer instruction thing, most of the students do end up learning it. And there's also been new research coming out where they actually had like recorders to track what people were talking about, and people come up with all kinds of interesting things that they're talking about while they're supposed to be doing this. But people are actually learning from it and not just copying their neighbor, which is a pretty cool result.
Just to your question too, timed contests are supposed to be highly anxiety producing. And also calling on somebody, although if you know them really well, you know, you can say, "Hey Joe, wake up, man, what do you think?" You know, and I do tease them if they're falling asleep, but you know, just to hit, or to stand up and say, "Pop quiz," that's anxiety, right? I don't know. Those are some things.
I think it's important that students know that they need to be able to solve problems on their own sometimes, because there's also a lot of students, they get in their little study groups, which is good, but then when it comes to tests and they're by themselves, they don't know how to solve problems. And so I think it's always important to remind students to be able to do it on their own as well.
I like that.
I also have students, remedial students who get a lot of tutoring. Whoa.
What? That was weird. Sorry.
Like our EOP students, as you were talking about, they have tutors, and the student will be partway through a problem, and the tutor, they'll stop, and the tutor will say, "Do this," or they will do it. And I want to do it so bad when I'm watching them, you know, and I think then that cripples them, because then they never have to stop and say, "Well, what do I do? Do I do this? Well, maybe not," and there's a reason. You know what I mean? So that's like the groups, what you were talking about, but it's also in a more structured tutoring.
But yeah, you have to be careful when you're helping someone one-on-one to just not just give the answer, but help them with the answer themselves.
I think another strategy, particularly with math, is making it fun. Like, you know, making it a silly activity, you know, like I was talking about when one of my teachers does Barbie bungee jumping, where you get little rubber bands and you figure out how much they stretch, and then you tie them together and you actually, you know, try to calculate how you can make the Barbie not smash into the ground, and then you actually do it. And it's like a simple math problem, but yet they're like, you know, hands-on doing it, thinking about it. I think we made posters afterwards, but it made it more of a fun math problem than just a normal everyday math problem, even though it was the same stuff.
And that kind of speaks to a couple of the points that I've seen and agree with. Is you want to make it fun, you want to make it humor, make it positive, people are being supportive of each other, but you also want to show the relevance of the math. You want to show how it's important to whatever, you know, science, physics, or biology or whatever, and also to real life. So like what I did for my dissertation chapter that I mentioned, I was teaching how to use matrices to model populations. And so I chose a specific example of these albatrosses that are dying of lead poisoning and how you use the model to help save that population. And for a group of, you know, environmentalists and ecologists here at UC Santa Cruz, that really spoke to them. And so they're like, "Oh, you really can do a lot more with math than you can do without math. This is cool." And so that was one thing that I thought was pretty important.
Can I piggyback on that? What you can do is just ask a colleague, "Can you give me 5 minutes in this class to just tell me how you use calculus, for example, in your field?" They will love it. The students will love it. You know, it's like, it's a real thing, and your colleagues, I don't know about you, but I love to talk about what I do. And so if you can find 2 or 3 people who, even grad students who are doing problems, I get grad students to come in and talk about, you know, environmental things we're solving at Humboldt. The students just love it. They eat it up. So, yeah, just to feedback.
Especially if the person that comes in maybe can speak to having had some math anxiety if they did. You know,
Yeah.
give them an example.
That's a great idea.
Yeah, I wasn't just born here, you know, using calculus.
Yeah, I usually try to tell them maybe I personally had math anxiety before and be like, well, you know, it wasn't easy when I started. This is how, you know, I kind of overcame it. This is like, I'm teaching you guys what worked for me. Maybe it'll work differently for you, but this is what worked for me.
Yeah, and you have to struggle. Almost all of us normies have to struggle. I don't know, maybe some brilliant people don't, but, you know, just can expect it, you know. So, yeah, that's great.
Another thing too, like with testing, a lot of people when they're studying, you know, like they have their coffee, their snacks, you know, like in a comfortable chair or whatever, so they're very comfortable. But then when you get to your test, you're, you know, this little hard chair and you've got like a clock right there. And so that stresses a lot of people out for testing. So I'll tell people to go, you know, get a room in the library, put a timer right in front of you and practice in the situation, like make it as much like the situation as possible. So you can get comfortable in that situation.
What were you going to say?
Oh, for you know, I guess one-on-one tutoring, in particular, students, you know, they'll be worried about trying to solve some problem, and I guess I try to let them take, you know, me and themselves down a dead end, even if I know that it's a dead end. And I let them go, and eventually we get to a dead end, and you know, we both recognize it, and then I say, oh, that's fine. All right, well, now, you know, now we know that doesn't work. Let's go back and, you know, let's try another strategy. And I feel like that, you know, having that feeling like, oh, you can go down dead ends. You can use the wrong strategy. You can make a mistake, and it's fine. You can roll back. You can find.
That's great, as opposed to the anxiety producing of saying, of course that doesn't work, let's do it my way. And never showing where it leads. Yeah.
Yeah, I usually like if I'm like working in like a PA setting and like I know like you know I'm starting to do a problem, then other students like talking, and so I usually instead of like continue with my way, I like go with their way, go through it, ask like the whole class, we start engaging, talking about like, okay, so they see this strategy, is this strategy working? Or sometimes I'll do the strategy and like kind of go on a wrong way and be like, okay, where did I go wrong here? And I will purposely make a mistake and then kind of get everyone engaged and talking, trying to like, and they usually, it results sometimes and they like get argumentative with each other, but once you get them really engaging and show that like there are ways of doing it wrong, they like see it's so easy, you can go back, this is how you check if something's going wrong.
Yeah. Sometimes I will do like a sheet, even for like a remedial, you know how there's like a quadratic of the x squared plus 4x, and they'll make it equal to 7 and then try to factor the x squared. And I'll have something like that. Is that right?
Yeah.
You know, just all these wrong, you know, not distributing the negative, or, you know, just examples. Find the mistake is their homework, you know. They got a whole sheet of mistakes. It's kind of like a game for them.
Yeah, I usually, I let them have a game, like trying to figure out where did I go wrong, you know?
Yeah.
And they get really into trying to figure out where did the teacher go wrong, and it makes them,
Yeah, smarter.
yeah.
You know, there are templates for Jeopardy online too, which you can just, you can fill in your questions, make them $50, $20. Just Google it. It's very fun. I tell a joke every day in class, and when I get evaluations, they don't care how I proved this or that. They mention the joke. Funny. It's just that way.
I have them when I'm starting up the class, and there's like maybe like 10 minutes before the class, and we're just starting, I have them tell me chemistry jokes, like that they've heard. Something funny, and they really just like saying, like, whatever joke, like, whatever science joke they've recently heard, even if it's corny. Even if I've heard it or not, I'll be like, oh, that's a funny joke.
And if you have a room with a screen and access to the internet, like sometimes I'll put on like the beginning song to the Addams Family or something, but there's like the Calculus Rhapsody online, you ever hear that? Funny as a crutch. And you can put that on before class and loosen them up a little to relieve the anxiety of, oh my God, I'm in calculus, and then launch in. So it's ideas. We got some more?
I heard just from a panel of TAs a few days ago, someone said, have a non-judgmental face.
Yeah.
And it seems like an obvious one, but it's easy to forget, you know, what emotion you're showing on your face. You might be thinking it, and it's on your face, you're not saying it.
It's a good one. And your tone too. You know, your tone of voice
Oh,
can be so important.
Giving students strategies on how to check their work too, it helps.
Yeah, that's great.
Sorry, go ahead.
Oh, we had talked about in our group a little bit about how to make them feel comfortable too, and that was telling them it's okay to be wrong, telling them that they can say no, it doesn't make sense. Or I think Zoe, I don't know where she went, but she had a good idea where she would ask them for wrong answers. Like, tell me your wrong answer, which goes along the lines of like, how did the teacher go wrong?
That's great.
You think deliberate, like making deliberate mistakes for them to catch for this to learn. Do you think that would be helpful for people?
I think as long as you make sure that it doesn't stand, that if they don't catch it, you correct it.
Oh yeah, you can do that.
Yeah, I was thinking about that one too.
Can I comment on the learning styles just as we're getting to the end?
You have a lot on that, so let me say one quick thing first. One other thing that I've seen is that you can also, people are more, like they were saying, people are more comfortable at home studying sometimes more than in lecture. And so one of the ways you can support math is to have online ways of doing it. And so have you guys seen the Khan Academy? They're like online videos where they go through different problems and stuff. And they have all kinds of different math things. So if there's one particular type of math that you see your students struggling with, you can say, hey, maybe you should go check out this video on Khan Academy. And they're really fun. They're scribbling all over the math page or whatever. And there's also another one that I think the one biology person, well, maybe Lauren is down here, but I wanted to do this when Ingrid was here. But it's this thing for biology where they show different kinds of math, and it's like an online module where you step through the different problems, and it gives you hints on if you do things wrong. And they have cute stories and stuff. And so it would be for like an introductory biology course, instead of, like struggling with exponential growth in class, you can go at home and it's you can go at your own pace, and they have fun stories that go along with it, and it's just low pressure. And one of the main reasons that they designed it that way is so that they're not activating math anxiety, so that people can just, do it at their own pace without pressure. And then you were talking about learning.
I just want to get 1 minute worth of it. If you look on your handout, they talk about, I think it's about the end, maybe the third to the last piece of paper. They have learning styles. They talk about the visual, auditory, and kinesthetic. And it's pretty straightforward what that's ways that we learn. And ways that, like, if you learn from hearing things and someone basically only writes it down, then you may have some difficulty learning it. Or if someone just says an assignment and doesn't write it down, a visual learner is going to probably not catch it. And a kinesthetic learner needs to kind of move and feel it and touch it or visualize it. And so reaching all those styles, research says, helps to reduce math anxiety, because of course we're all of them, but we can be primarily one or the other. And if you look at the very last page and our past piece of paper, there's a questionnaire you can do you know, sometime when you've got nothing better to do, which I don't know when that'll happen, but you can find out which kind of learner you are. And then there are certain strategies that are better for reaching you or these students who are of the various types. So that's probably all I have time to say. Thank you.
Can I throw something in?
Uh-huh.
You all right? So, my master's in bong hitting, you know, if they gave it out, I guess I'd have a PhD in recovery. Is anybody in 12-step? So I've got 24 years, which is almost half my life, in 12-step, thousands of meetings. And Patrick, I wanted to jump up and down and shout in applause with what you said, because what you described is why 12-step works as a fellowship of people support, peer support. And I heard a lot of comments about don't shame your students, and a lot of communication skills implied in a lot of the comments. And that works in recovery from addiction. And if it works there, it probably would work with something less life-threatening than, you know, a little math anxiety. But I also heard all this human element. God, we're so complex and so complicated and at times so mysterious. There's a human being there. And you don't know what is going on in that person's life. And you don't know what went on in their life 20 years ago when they were 4 years old. And it's easy to assume. But all the comments sounded fantastic. So that's just my 2 cents worth.
Thank you.
One of the things to wrap it up is if you have students in your class that you can tell are struggling or they tell you that you're struggling. I talked to one of the counselors at the Counseling and Psychological Services, and she said, you know, just try to make whatever accommodations you can make, whether it's flexible, that someone wants to have earplugs while they're taking a test, or sit in the back of the room, or walk around or whatever, you can do that. But if someone is really struggling, you can send them to the Counseling and Psychological Services here on campus. They're about to start quarterly workshops on test anxiety. They actually have, this Christina Aranda is actually a psychology postdoctoral fellow that is focusing on test anxiety. They also do individual group counseling, and if you as an instructor have questions that you want to ask them, she'd be happy to talk to you. So her email address is on the handout with a list of resources. The Disability Resource Center can also be helping people with math anxiety. They might need to get a letter from a counselor, and then they can suggest and provide accommodations, like a separate room to take a test in or whatever people might need. And then Learning Support Services can also help students to work in groups and learn how to prep for tests and have good study habits, that kind of thing. So those are the 3 avenues that we have here at UCSC. Unfortunately, none of them is specifically math anxiety, but there's a lot of overlap with other things as well. And if someone does go to a psychologist, there's all kinds of different things they can do of managing anxiety and relaxation, kind of just helping people to change the way they think of seeing it as a challenge rather than a threat. I don't know if there's anything else you wanted to add.
I got one more I forgot. I heard some key words like people feel like they're freaks. Students feel like they're freaks and they're broken. And that peer support, when they get with other people, they might hear the same thing out of their peer's mouth and they go, oh my God, I'm not alone. I'm not alone in this. And then another thing that recovery people do is they say, okay, you're sober a year now, you want to stay sober, go help somebody who's brand new. Because you have something to teach. And it builds them up, it builds up their confidence.
I think we need to end. It's about 1 o'clock, is that right? But I just want to thank you so much for coming. I'm so impressed that you're all trying to do a better and better and better job of your work. And thank you for listening to us. And thank you, Kristin, for bringing me here. Thank you. Thank you all.
And if you want to stay and talk, feel free. But if you have to go, we understand.
Yeah, thank you.
And feel free to have desserts. There's a lot more desserts and drinks. Please take them, because otherwise I will eat them all. Or we'll donate them to the Grad Commons. So. And I will email out the list of instructional things for the other things.
Yes, sorry for distraction last week, but lecture and to through things
Thanks for organizing.
Yeah, thanks for coming.
I emailed you for
Cartoons from out.
Don't forget your coffee mug, Carl.
Right here.
Oh, thanks.
So,
That will be loud.
thanks for coming.
I think the calculus students that I actually
This guy's Stephen Adam, works on the and his
They know what?
We're biologists.
We have a 3 hour